So this is the last video on tractability. We've been looking at how intractable problems grow out of control, and you can go back in the previous videos and look at that. And in the last video we looked at not just the travelling salesman, but there's a bunch of other problems that have a similar tractability issue: bin packing, knapsack, stock cutting, and factoring. Some obvious and relevant examples. So for the DCAT we need to look into how this is relevant. Why do we study a topic like this? Now obviously if you're a travelling salesman there's a relevance to what we're doing, but it goes beyond that. Anything where you've got a bunch of destinations, so typically logistics companies, which are all about those big lorries you see going up and down the motorways around the country. They've got different places to get, different loads to get there, different times, different delivery dates, and those problems increase in complexity in the same way the travelling salesman problem does. Courier drivers similar as well, and of course they will use heuristics to actually solve their issues. Airlines have quite a similar bunch of issues as well. Of course they've got to get planes to places and people to places, and the complexity of fitting all of the pieces together to make an airline work is an intractable problem, but obviously there are many heuristics to resolve that, and there's a few others of similar nature. Here's one that most people wouldn't have thought of. When you're making PCBs, like circuit boards for electronic components, a machine does that, and a machine can be either inserting components. I'm just going to show you here. This is a machine that's inserting components onto PCBs. And of course it has many components to insert in many different places. These machines are super expensive and their time is money. So obviously you want to optimize the path that the head of the thing takes so that it goes as quickly as possible. Just scrub through to a bit where it's doing a bit more of that. There you go. So that problem is, very much the same. It's the travelling salesman problem. How do we get all these things to these places on the circuit board? And if you can make a 10% improvement on a poor algorithm, well, that machine is then paying off 10% faster, the money that's invested in it. So it's very relevant. Stop that. So that's some obvious travelling salesman applications. Of course, there's obvious applications as well of bin packing, knapsack and stock cutting. They're kind of real world ones. Any situation where you need to fit a bunch of resources into containers is where an intractable problem. And strangely enough, computer science can have issues like that as well. If you've got some resources you need to use and you need to either schedule them or allocate them in an efficient way, that can be an intractable problem. And then obviously there's the foreign key encryption, which you looked at previously. I asked you to look on the computer science field guide. In the video it comes up that factoring if you multiply together two very large prime numbers to get one extra larger number and then give that to someone, the problem of factorizing it back into its two prime numbers is intractable, and that's a good thing because that means that you can do foreign key encryption, which enables things like credit card transactions over the internet, or any security at all over the internet would not work otherwise. We're done here. We just need to start looking at the DCAT now and the writing side of things. So pretty much everything that I've covered in these 6 videos is what you need to write about. And to be quite honest, not in a massive amount more depth. You just need to explain a little bit more carefully and clearly than I perhaps have done, and it'll be easy, be done. So it's not a particularly hard DCAT to write.